Hey guys, welcome to 4-6. In this section I'm going to talk to you a little bit about conditional probability, and we're going to basically build the bridge to the concepts that we were talking about in 4-4 and 4-5. So what I wanted to start with first is just a simple Venn diagram question. So we are going to consider the idea that there are 50 grade 9 students that have been surveyed, and they were asked about their subjects that they like, and out of those 50 students who were asked the question, we found out that 34 like math, 22 like science, and 10 like math and science. Okay, so in that information in our sample set, okay, we are going to create two sets, one that corresponds to the students who like math, the other that corresponds to the amount of students who like science, and then looking at the union in between them in that overlap. Okay, so in that overlap we have 10 students who like math and science. Oops, I lost that. Let me go back. Okay, and then students who like math, so 34 take away 10 leaves us with 24 students who just like math. And then for science, we got 22 students, so 22 subtract 10 leaves us with 12 students. Okay, so ideally what we're looking for is that when we calculate our total, we got 24 plus 10 plus 12. We want to ensure that we actually get the 50 students that were surveyed. So the thing is when we add up these values, we have 46. So essentially what that means is out of your sample set, there are 4 students who don't like math or science. Okay, there are 24 just like math, 12 that just like science, 10 that like the overlap of both, and then 4 students who don't like either. Okay, so you can see they're still in the sample set, they're just not in the sets for their grouping of math and science, okay, but they are still included because they are still in the rectangle. All right, so let's find the probability of students who like math out of those who are interviewed. Okay, so the number of students who like math, so just any basic probability is taking the number or the total of students that you're interested in divided by the amount of students, in this case, that were surveyed. Okay, so in this case there were 34 students who enjoyed mathematics out of the 50 students who were asked. We would of course simplify that into lowest terms, and we would figure out that there's a 68% probability that students enjoy math. Okay, now we'll segue a bit into this idea of conditional probability. So for conditional probability is the understanding that we are now considering another event. Okay, so we have event A. Now given that event B occurs, how does that shift the probabilities that are at hand? Okay, so what we'll look at here is what is the probability that a student likes math given that they like science. So what I just drew there is a vertical line, and that vertical line means given. Okay, so something that has to occur. They have to like science, but they have to like math given that they already like science. Okay, so we're actually looking at a different set of data here, and we're actually going to shrink our sample size quite a bit because we're only going to be looking at the information that is now highlighted in green. Okay, so to do this, we got to figure out the number of students who like math and science, so again the overlap, and divide it by the number of students who like just science. So in that, we have 10 students who overlap out of the 22 students who do like science. We can simplify, and this approximately is 45%. Okay, so the new portion of what we're doing in today's lesson is looking at conditional probability. Okay, so in some cases, the probable outcome of an event depends directly on the outcome of another event. So like this example with the students who like math, given that they already like science. So there is a relationship between the events because we are actually depending on the outcome of it. Okay, so when this happens, the events are said to be dependent. The conditional probability is a probability of an event A occurring given that another event B has also occurred. And how we write it in terms of our notation is the probability, open bracket, of A given B. So again, that vertical line means given. Okay, we're going to be using this formula right here. And that formula reads the probability of A given B is equal to the probability of A and B, so again looking at that intersection and dividing it by event B. Alright, so here we go. We're going to start talking about some card examples. So I realize maybe some of you aren't really familiar with a playing deck of cards. So let's just go over some basic card knowledge. Okay, so a basic deck of cards has 52 cards. Okay, that's not including our joker. And there are 4 suits. Okay, so the 4 suits, we have hearts, we have diamonds, we have clubs, and then we have spades. There we go. Okay, so in that, what we're going to do is we're going to consider the probability that a card that we draw is a jack, given that it is already a face card. Okay, so just some knowledge on face cards. So face cards obviously are cards that have faces, and that pertains to jack, queen, and king. Okay, so what we're actually looking for is we're going to find the probability of jack given that it is a face card. Okay, so first we need to find the overlap. So what is the probability that it is a jack and a face card? Well, there are 3 faced cards and there are 4 suits. So 3 times 4 is 12. I'm sorry, I went ahead and I did the next one. Jacks and face cards, so there are 4 jacks that are face cards, and out of 52 cards. Okay, now the probability of just the face cards, this is what I was talking about a few moments ago. So there are 3 suits, 3 face cards, sorry, not suits, 3 face cards, multiplied by 4 suits. Okay, so that means that in total there are 12 face cards out of a deck of 52. Okay, so now to find the probability that it is a jack given it's a face card will be 4 over 52 divided by 12 over 52. Okay, so how to divide fractions? Well, always rewrite your first fraction, and then we're going to take the reciprocal of the second fraction. In this case, what you'll notice is the 52s cancel out, so I'm actually just left with 4 over 12, which is 1/3. Okay, so there's a 33.3% chance that we will draw a jack given that it is a face card. Alright. Take a look at this box here. So this box says the conditional probability formula can also be arranged as one method of determining the compound probability of probability of A and B is equal to the probability of A given B multiplied by the event of probability of B. Okay, so in that, we want to see what is the probability of drawing 2 aces in a row from a deck of cards if the first card is not replaced. Okay, so sometimes what happens is in probability type questions, you might take a card out of a deck and it is left out of the deck. So meaning when you draw your second card, there's not 52 cards anymore. There's one less. There's now 51 cards. Okay, so just keeping that in mind as we're doing our probability questions. Okay, so in our events that we're going to consider here, we're going to let event A represent our first ace. Okay, because we are trying to draw 2. We'll say let event B represent our second ace. Okay, so what's the probability of event A happening? Well, there's 4 aces in a deck out of 52 cards. Pretty straightforward. Okay, now we're going to now draw a second card. So this is going to be the probability of our second ace given the fact that event A has already happened because we've already taken out one card. So what this means is there's not going to be 4 aces anymore, right? There's now going to be 3 aces. Okay, the potential that 3 can happen. And we have now taken out one card, so instead of it being 52 cards, we now are left with 51 cards. So, given the formula that was discussed above to find the probability of A and B, we're going to take our probability of 4 over 52 and multiply it by 3 times 51, or 3 over 51. Okay, so what we would have there, we might need to use our calculator a bit. 2 times 51, oops, 2652, okay, 2652, so then that simplifies to 1 over 221. Okay, so that's the probability of drawing 2 aces in a row from a deck of cards if the first card is not replaced. Alright? Cool. Okay, so we'll move on to our last question for this section. Okay, and this section again is one that deals with cards. So I'll just read it out first. Suppose the 2 jokers are left in a standard deck of cards. Right, there's 2 jokers. One joker is red and the other is black. A single card is drawn and not replaced, and then a second card is drawn. Okay, so what's important here is a single card is drawn and not replaced. We want to determine the probability of the following now. So one of the jokers on the first draw and an ace on the second draw. Okay, so what is the probability of drawing a joker? Okay, well, there's now 2 jokers that are included in that set, and instead of 52 cards, we have to add plus 2, so it's 54, which is equal to 1 over 27. And then we want to figure out what is the probability that we draw an ace, given that the first draw has already happened. Okay, so in that case, there are 4 aces in a deck of cards, and because we did not replace the card, we have 53 cards now, so 1 less. So the probability of A and J is equal to 4 out of 53. Now we're going to multiply it by 1 over 27, which equals 4 over 1,431. Okay, so a really small probability there. If we wanted the percent, that's about barely 1%. Okay. All right, now let's look at our last case. So we have a numbered card of any suit on the first draw, and the red joker on the second draw. Okay, so let's consider first event A. So we want the probability that we draw a number. Okay, so we said earlier that there were 12 face cards. Okay, if there are 52 cards, 52 take away 12 leaves us with 40 numbered cards. Okay, and in this case we will consider ace as a numbered card. And we have 54 cards because we are still including the 2 jokers. Now we want to figure out, in the event that we draw a red joker, given that the event of the number card draw has already happened. Okay, so a red joker, that's 1 out of now 53 cards because the cards have not been replaced. So once again, we're going to find the probability that we pull a red joker and it's numbered in that combo. So we have 40 over 54. I guess we could have simplified that. Let me simplify that now. So 40 out of 54 should simplify to 20 over 27. So let's use that. 20 over 27 multiplied by 1 over 53. Okay, so that takes us to 20 over 1431. Okay. All right, so that's our talk on conditional probability. There are 4 homework questions that I'd like you to look at. Your answers are at the bottom. And in accordance with the 4-6, I'm also going to get you guys to complete, there's a couple questions on independent probabilities, and that's a sheet that will come separate. However, just